Dear students, in this section, we will discuss about high pressure boilers, and the boiler is the Lamont boiler. So, Lamont boiler, it is a high pressure boiler. Now, there are some features of the Lamont boiler. Lamont boiler, it is a forced circulation type of boiler. It means in this boiler, we use the forced circulation, but it is a water tube boiler, and this boiler was first introduced in 1925 by Lamont. Lamont is the name of the scientist who devised this boiler. The most of sensible heat is supplied to the feed water passing through the economizer. It means we give the heat to the feed water, but most part of sensible heat is supplied to the feed water in the economizer. Means economizer is the section in which most part of the sensible heat is supplied. A centrifugal pump circulates the water equal to 8 to 10 times the weight of steam evaporated tubes. It means the centrifugal pump is utilized there, and which circulates 8 to 10 times the weight of the steam. Whatever the amount of steam evaporated, it's 10 to 8 to 10 times the water is circulated with the help of centrifugal pump. These boilers have built up to generate 45 to 50 tons of superheated steam at a pressure of 120 bar and a temperature of 500 degrees centigrade. Means this boiler is having its steam generating capacity which is from 45 to 50 tons. It operates at the pressure of 120 bar and at a temperature of 500 degrees centigrade, which is the maximum limit. But in this boiler, there is a main difficulty, and this difficulty is the formation and attachment of bubbles on the inner surface of the heating tubes. Means because it is a water tube boiler, so water flows inside the tubes. But when the water is converted to the steam, there is the formation of the bubbles, and the bubbles are attached on the inside surface of the tube. And because of the attached bubbles to the tube surface, it reduces the heat flow because it will form a layer of the bubbles, and that layer will resist the flow of the heat from the hot gases outside the tube or pipe. And because of this, it reduces the heat transfer rate because of this high thermal resistance of the film of the bubbles. So this is the main difficulty in Lamont boiler. Now we will discuss about the functioning of the Lamont boiler. So this is the schematic diagram for the Lamont boiler. So from the top side you can see that this is a blower and the cold air is coming from this side. So cold air will come with the help of the blower and it passes through this air preheater section. This is the air preheater section here. And because air will pass through air preheater section, and from this side you can see the hot gases are moving upward. So the hot gases before going to the chimney or before exhausting to the chimney, they will give their heat to the air passing through air preheater, and this warm air when goes to combustion chamber, it will increase the combustion efficiency. So this is the utilization, or this is the heat recovery device for this boiler. Now here you will see there is a feed pump, and this feed pump will draw the water from the hot well, and this water will pass through this section, passing through these pipes or the tubes. So this section is called like the economizer. In the economizer, because we are utilizing most amount of the sensible heat, so most amount of heat of the hot gases is utilized in the form of sensible heat to heat the water in the economizer. Then after being heated water in the economizer, it goes to the steam separating drum. This is the steam separating drum where the water comes from the economizer. Now from this steam separating drum, the water will follow this passage and then here it will enter the radiant evaporator here. So here you can see we are using a circulating pump. This is a circulating pump and this is a distribution header. So with the help of circulating pump and distribution header, the water goes to radiant evaporator. Circulating pump is required because we have to force the water to flow through the radiant evaporator, then convective evaporator, and then again comes back to the steam separating drum. So we need a circulating pump. And now this section, which is called as a radiant evaporator, because here there is a combustion chamber and the radiant evaporator is located near the combustion chamber. So in the combustion chamber or the furnace, we burn the fuel, it produces hot gases. So because of this combustion, high heat is developed, high heat is produced. And because of which the temperature of that combustion chamber is very high. And radiant evaporator is located near this combustion chamber, so it gets heat from that combustion chamber in the form of the radiation. So the water inside the evaporator is being converted in the form of the dry steam, but it also carries some amount of the water particles, so it is the wet steam actually. Now after passing through this radiant evaporator, this mixture passes through this next evaporator, which is called like the convection evaporator. So the name of this evaporator is the convection evaporator and the mode of heat transfer here is the convection. And in the convection, because this mixture is passing inside the tubes and from the outside, we are seeing the hot gases are moving upward. So the hot gases outside the tube or the pipe gives heat to this mixture and it forms or it converts totally the water into dry vapor and getting heat from this section, this steam or dry steam goes to the steam separating drum again, but here it is stored at the top of this steam separating drum because the dry steam is lighter and the water is there, so water is at the bottom side. Now here at the top side we are having the dry steam. So dry steam with the separator is separated and then this dry steam is passed through this section for the superheating purpose. So this section is called like the superheater. Here also the hot gases are moving through this superheater section. So here when these gases will pass through this section, the dry steam will be superheated and then this superheated steam is ready to be used either to the steam to prime mover or for the other our requirement or other applications. So in this way we can say this Lamont boiler is functioning or functions, but the main difficulty in this boiler is the formation of the bubbles which reduces the heat transfer rate. And so this problem was solved by the Benson. And Benson is the modified form of the Lamont boiler. So that will be discussed in the next my next lecture. Thank you.